I needed a system to drive multiple turnouts at once to help route trains through a hidden staging yard on the new section of my layout. And I built the system powered by an Arduino and some relays, and I'm going to show you how on Ron's Trains and Things right now. Hi, I'm Ron of Ron's Trains and Things, and I'm in the process of building a hidden staging yard behind the new section of my layout. And I needed to be able to route trains into this staging yard from the layout side of the wall. Now, in my last video, I showed you how I built a control panel in order to control this routing system. And today I'm going to show you how I built, wired, and programmed the heart of this system using an Arduino and some relays. Now, this process gets a little bit technical at times, and I'm going to tell you right from the outset that I am no professional when it comes to high-end electronics or programming and coding. But I'm going to show you what I learned and how I built it, and I'm going to tell you from the beginning, this system turned out to work really, really well. Now, if you'd like to see more model railroad tips, tools, and techniques, be sure to subscribe down below. Click that little bell icon so you can catch future videos. But now, let's go take a look at this Arduino project and the logic system for routing trains into my staging yard. This video is brought to you by Midwest Model Railroad. Now with 15,000 square feet and one-day shipping, they truly are your one-stop model railroad shop. MidwestModelRR.com. Link in the description. These are the components that will comprise my routing system. And of course, on the left, you will note the control panel, which I built in my last video. And what you see here is an Arduino Uno and an 8 relay board. And then this is mocked up with some small temporary push buttons. Obviously, this will be run from the push buttons on the panel that I just showed you. But I've set this up to where, of course, there are 3 turnouts that run the 4-track staging yard. Each turnout needs 2 relays to be able to switch the polarity and thus switch the direction of the routes. And I've set this up to work by writing a sketch for the Arduino, and it works great. I'm going to show you in just a second. Right now, powering it just off a 9-volt battery for a mock-up. I could also power it off of my bench supply. This powers through, they recommend 7 to 12 volts. So I'm going to actually power it right off of the 12-volt bus on my layout that is set up for accessories, and is run by the ATX power supply that I modified and made a video about some time ago. But as you can see, of course, right now I've just reset this, but if I push button number 1, it sets the relays to route into the first track. Button number 2 changes the relays so into the second track. Button 3 for the third, and then button 4 obviously for the fourth. Now I'm going to do my best to explain to you the wiring connections for this particular setup, and then we'll also talk about the sketch that drives it. First of all, the wiring that connects the components together. The relay board is connected to the Arduino, first of all, with this 8-wire ribbon, which connects the 8 connections for the 8 relays on the relay board to pins 2 through 9. Those are digital pins 2 through 9 on the Arduino. Very straightforward. Just make sure that the colors match up and correlate. Also, the 5-volt output pin on the Arduino is connected to the 5-volt input on the relay board, and the ground pin, one of the ground pins from the Arduino, is connected to the ground pin on the relay board. That powers the relays. Now, understand, and this will be important later, that because this powers the relays does not mean that it powers the tortoises. That power will come from an outside power source. We'll talk about that in a few minutes. So those are the connections from the relay board to the Arduino. Then from the Arduino to these switches, and again, these are just mock-up switches, but first you'll note that there is a black wire that goes from the ground pin on the Arduino to the ground rail on this breadboard, and then that is connected to one side of each one of these buttons, so that each button is connected to ground on the Arduino on one side. And then on the other side, each button is connected to pins 10 through 13, digital pins 10 through 13 on the Arduino respectively. So this one, button 1 to pin 10, button 2 to pin 11, button 3 to pin 12, button 4 to pin 13. And so that is how the wiring of the components work. Now, when it's hooked up on the layout, the only difference that will be is the fact that these little short wires connected to these temporary buttons will be longer wires that will connect to the actual momentary switches on the control panel. Now, let's talk about the wiring as far as what drives the tortoises. And that brings us to our relay board up here at the top. Now, what I want you to understand a few things, and I'm going to try to do some drawing here that will hopefully help you out. Again, as I said earlier, each tortoise needs 2 relays to be able to switch the polarity and thus throw the tortoise one way or the other. So these first 2 relays are going to work together to drive tortoise number 1, and then the next 2 relays are going to work together to drive tortoise number 2, and the 2 relays after that will work together to drive tortoise number 3. Now, I will use this next relay not for any work with the tortoises, but because I need an extra switch to throw the 4th indicator light, LED. Each of the other LEDs will be thrown by the internal switches in the tortoises. We're going to talk about that probably in a completely separate video, but just want you to know this is going to only power the one light. The last relay will not be used at all. Now, as you look at these relays, each relay has 3 terminal screws, and in this picture, they don't line up perfectly. They don't line up perfectly in real life either, but this picture, just the angle of it makes it look a little bit even harder to understand. So I'm going to draw some lines here. I want you to see where the division is between these 2 relays and between their terminals. Right there, and then up through here, and then through here, again here. This one goes this way a little bit. This one in the picture is even further off. But the point that I want you to see is that each relay has 3 terminals, and I want you to be able to see where those are divided. Now, there is a normal on connection on each one of these relays. And in this picture, let's use this light green color, it is the left-hand pin. The center pin will be the input pin, and then it's connected when the relay is not thrown to one pin, and when it is thrown, it's connected to the other pin. So what they call a normal on is going to be on the left side. So these 2 are normal on, these 2 are normal on, these 2, these 2, these 2, these 2, and I'm not worried about that one. So those green lines are connecting the normal on. So when the relay is not thrown, it's connected to this pin. When the relay is thrown, it's going to disconnect from this pin and connect to the other one that's not connected to the green line. Okay, I hope that I'm not moving too fast, and I hope this makes sense. Now I want to draw some lines that are going to indicate the power into these relays. Again, 2 relays for each tortoise, and that's because one is going to handle, let's just say black and red, because that's the colors I usually use. One will handle a black wire, one will handle the red wire. Remember, this is DC, so polarity is what matters here, and as long as we keep our colors consistent with the polarity and our power source and our tortoises, it'll all come together. So for each tortoise, one relay is going to be connected to my red wire, that particular pole, if you will. And in this case, the first relay of this tortoise, the first relay of this tortoise, and then this tortoise, the first relay, that center pole is going to be connected to the red wire or the power wire, whatever you want to call it, and that's going to go off to our power source, which in my case is the 12-volt power bus powered by my ATX computer power supply conversion. And then the other relays are going to be connected to the other pole, or in this case, the black wire. So here we're just going to come a little further up. Get the center there. Yeah, make sure I get the right ones. Again, the center pole from each relay connected to this wire, and that's going to go off to our power supply. Okay. Now, next we're going to talk about the wires that go from these relays to our tortoise. And for this case, I'm going to use green and blue, I think, for my two different wires, just to differentiate them from the red and black. So if this is one wire going to my tortoise, this red wire needs to be connected to one wire, and that's going to be the green one. And this is the normal on position, which means that if this is the other wire going to my tortoise, it needs to be connected to the other wire, which is the blue wire. Okay, so now in the normal position, these two wires, separate wires, going to the same tortoise, and they will have the tortoise thrown into one particular position. Now, whenever I throw the relays, and I'll throw both of these relays at the same time, instead of powering this pole, it's going to power this one. Same here. Instead of powering this pole, it's going to power this one. So to switch the polarity, I want to switch the wires that are connected. So in this case, the red wire, instead of being connected to the green, will be connected to the blue over on this side. And the black wire, instead of being connected to the blue, will be connected to the green on this side. If I can connect these together, these two green wires will connect to this particular tortoise. And I drew those lines a little too long, but you'll get the idea here. These two blue wires will connect together, and those will go to the same tortoise. So that however this is thrown, it will change the polarity. And we just repeat that exact process for these two relays for the second tortoise, and these two relays for the third tortoise. I hope that makes sense. I hope that's at least as clear as mud. But the simple part of it is whenever these two relays are thrown at the same time together, it will switch the polarity of these wires from green to blue or blue to green whenever they're thrown. Now, let's take a brief look at the sketch that drives all of this and makes it happen through the Arduino. And here is that Arduino sketch. Now, if I look at it and scroll all the way down, it looks, moderately long, not super long, but understand that it's fairly repetitive once we get down into the meat of it, and I'll explain that in a little bit. The basics here, and I'm not going to try to go through the entire sketch and explain it, but I just want to help you understand the basics. First of all, we're going to begin by declaring our various pins that connect to both the relays and the buttons. And to save some space in the sketch, I used arrays to do this. So this first line right here is an array that declares that the relays are connected to pins 2, 3, 4, 5, 6, 7, 8, and 9. And I did that. You could do that in one line with an array rather than do it in 8 lines. The next line shows an array that declares the buttons connected to pins 10, 11, 12, and 13. After that, I had to declare some states that are button old and button new for each of the buttons. And of course, in computer language, instead of 1 through 4, they're buttons 0 through 3. And so basically what I did here is declared a button old value for each pin of 1 and a button new I just declared button new, so it doesn't have a value assigned to it. And that's for each one of the buttons, and I'll explain that a little more in a moment. And then I put in here a delay for the purpose of debouncing, and we'll talk about that again in a minute as well. And that delay is 50 milliseconds. And so those are the things I had to declare at the beginning. And then a setup, I basically used a pin mode to declare all of my array values to be outputs for the relay array. Those pins are outputs. And then declared the value of each one of those starts at high. These relays at their normal state is at high, or at high voltage, or 5 volts. But then this is the real heart of the sketch here. This is what I want you to see. In my loop here, I have basically set it up to where it reads each button each time in the loop. And what it does is it reads whenever the button, not when it's pushed, but when it's been pushed and it is released. So it's just the way that Arduino and C++ works. When a button is pushed, it reads 0. When a button is released, it reads 1 on a digital pin. So what it's doing here in each one of these repetitive little sketches, if statements, is it's trying to recognize when the button old, or the former state of the button, is 0, which means the button has been pushed, but then it changes to 1, which means the button has been released. And when that happens, then it sets the relays to a certain pattern. And you'll notice here that relays 0 and 1, which drive the first of my tortoises, when button 0, or the first button, has been pushed and released, then those two relays are set to low, which means that they are set to turn that tortoise to the diverging route. And the other tortoises are all set to high, which means that they are all kept on the normal route. Then as you move down to the second set, you'll see here this deals with the second button, or button 1. And when it is pushed and released, then the two relays for the first tortoise are set back to high, so they go back to normal. And the second tortoise, those relays are set to low, which means it is set to diverging. And then we just continue on down with the third and fourth buttons doing the exact same thing. You need to notice here, as we do each one of these, is again, it's recognizing each button when it has been pushed, so 0, and then released to 1. So after that has happened, then the button state has to be changed back to the most recent. So that's what this button old equals button new line does. And then after each one, there's also this delay, DT, which is that delay of 50 milliseconds. And that's for the sake of debouncing, because it's nearly impossible to push a button physically cleanly enough for a computer to read it as a single button press. There's connections that are made and lost in there extremely fast, and it can confuse the computer. So what you want is you want it to recognize one connection and then have a brief pause so that it can complete the steps that it's supposed to complete for that connection, rather than reading multiple connects and disconnects. So after each one of these, there is this delay time, and that is basically the entire sketch. And that combination of hardware and software drives this routing system, and I have to say, it works great. You could use the same process for a yard of any size simply by adding more relays. In a future video, I'll show you how I installed this entire system, including track, tortoises, Arduino control panel, and wiring. So be sure and watch for that. This project took me some time to research, design, troubleshoot, and build, but I am so glad that I did. I learned a lot in the process, and I have to say that it was a lot of fun, and I'm very happy with the way that it works. I do want to say a word here about the value of community in our hobby. When I first conceived this project, I knew exactly what I needed to do, but I really didn't have a very good idea about exactly how to go about doing it. But I have a small group of model railroad friends who communicate often, daily in fact, and we all have different areas of expertise in the hobby. And together we were able to brainstorm and troubleshoot this project at every step along the way. And they were a huge help in helping get me to the goal that I had in mind for this project. And I really appreciate their value. I can't say enough about the value of model railroad clubs, social groups, or even connecting with model railroaders on social media for the sake of the fellowship, but also for the mutual help that it offers. Guys, you know who you are. Thank you. I appreciate you. Now, the main components that I used in this project are all going to be linked in my Amazon pick of the week in the description down below. And while you're there, you want to check out my MicroMark 10% promo code and the other valuable links that are there in the description below. Now, if you'd like to see this entire staging yard project or other model railroad content, check out the links on your screen. And be sure and join me on Tuesdays as I bring you even more great model railroad videos. And I look forward to seeing you then. 10, Lizzie?